When you're first starting algebra, suddenly having to do math with numbers and letters can be overwhelming. So here are all of the very basics of algebra, even for complete beginners. So basically the whole point of algebra is to take numbers and letters and just move them around to accomplish whatever you need to do. In algebra, these letters, like this one here, are called variables, and they're basically just like an unknown number. It's a number that you don't know. So in this problem, for example, x is equal to something. It could be equal to 5, it could be 500, it could be -7, it could be any number. And whenever you have the same letter twice in a problem, like there's an x right here, that means these are the same number, but we don't know what that number is. Now, one of the most important things you'll need to do in algebra is called simplifying. And that's basically taking something that's more complicated than it needs to be and shrinking it down by combining different numbers. Now, you might be wondering what 4x means because there's no sign in between 4 and x. Like, are we adding together 4 and x, or are we subtracting? But actually, when you have a number and a letter next to each other, it's multiplication. By the way, if you ever see people using a little like dot symbol, that means multiplication as well, because using an X symbol for multiplication for algebra when there's already X's everywhere, it just gets confusing. So one of the most important things to know is that you cannot add together something that has a letter and something that doesn't. Because we don't know what X is equal to, we can't add 4x and 3. So we just have to leave this as it is. But if you have two numbers that both have the same letter in them, then we can combine them because those are called like terms. So if you have 4x and 2x and you want to add them together, you can just do 4 plus 2, which is 6, and then the x is going to stay. So 4x plus 2x becomes 6x. And just like regular math, you can also add together just numbers. So we can add together the 3 and the -5. Whenever you have minus signs, they have to stay attached to their numbers. That's really important. So +3 minus 5 is -2. So what we've done is we've taken this top part, which is kind of confusing, and we were able to shrink it down into 6x minus 2. And we can't do anything more with this, so this is considered the fully simplified form. Now in algebra, sometimes you'll just have letters by themselves, like x, but other times you're going to have exponents on those letters or on those variables. So you're going to need to know how to simplify these. And here's the important rule. Even though this, for example, like 5x squared and 3x, even though these both have x in them, we cannot add them together. For something to be a like term, they have to have the same letter and the same exponent. So we cannot add these together, but we can combine the 5x squared and the 2x squared. Because they both have x squared, we can combine them. We can combine like terms. So 5 plus 2 is 7, and they both have x squared, so the x squared is going to stay. And these combine into 7x squared. Now, just like the last problem, we can also combine together things with just x. So here we have a 3x, and here we have a -x. And it might be kind of confusing because we don't have a number in front of x. But whenever you don't have a number in front, that's basically just an invisible 1. Because remember, this is multiplication here. This is 3 times x. And anything times 1 is itself. So if it's not being multiplied by anything, it's being multiplied by 1. So 3 minus 1 is 2, positive 2. And because they both have x, the x is going to stay. So 3x and -x combine into 2x. And now all that's left that we haven't combined is this +8. But it doesn't have anything to combine with because there are no other just numbers by themselves. So that's just going to be attached to the end as +8. So there we go. We've taken this expression with 5 parts in it, or 5 terms technically, and we've turned it into one with just 3 terms, but we can't simplify this anymore. So this is the fully simplified form. Now we've talked a lot about adding and subtracting, but what about multiplying? One of the most important rules in algebra is called the distributive property. And that's basically what happens when you have a number in front of parentheses. And remember that the rule still stands about when you don't have a sign. When you just have a number, and in this case, it's a set of parentheses next to each other, that means multiplication. So these are being multiplied. So whenever you're multiplying out a number by a bunch of parts, in this case, 2 parts, you need to distribute the -3 to all of the parts. So we need to multiply the -3 to the 2x and to the -4. Remember that the minus signs always stay. So first, let's multiply -3 times 2x. Well, remember that 2x also has a multiplication sign in here technically. So it's -3 times 2 times x. So -3 times 2 is -6, because 3 times 2 is 6, and there's one minus sign. and then that's negative 6 times x. And we can't multiply a number and a letter, so it's just going to stay as negative 6x. And then the second part of our distributive property is negative 3 times negative 4. 3 times 4 is 12. And we have two minus signs, and two negatives make a positive. So that's going to become positive 12. So using the distributive property, we've multiplied it out, and our multiplication results in negative 6x plus 12. Now, the distributive property is what we used to multiply things together. But in algebra, it's just as important to know how to unmultiply. Basically, take something that's already multiplied and spread it out. And we call this factoring. So let's say we wanted to factor 12x squared plus 8x. Well, to do this, the easiest way to do this is going to be using the GCF, or the greatest common factor. Basically, we want to figure out what's the biggest number that we can pull out of both of these. What's the biggest number that we could divide out from both of these? It's kind of like simplifying fractions. So let's look at the numbers first, then let's look at the letters. So the numbers, the biggest number that we can divide out of these is, well, maybe it's 2, right? If we divide 12 by 2, we get 6. And if we divide 8 by 2, we get 4. So we can divide 2 out of both of these. But actually, the biggest number that we can divide out of both of these is 4. Because if we divide 4, 12 divided by 4 is 3. And if we divide 4 out of 8, 8 divided by 4 is 2. So how we're going to do this is we are going to rewrite this, except we're going to put 4 on the outside. And on the inside, we're going to divide all of these by 4. So 12 divided by 4 is 3. And the letters are going to stay the same in all of this. Plus 8 divided by 4 is 2. And the x is going to stay. So as you can see, we're doing the opposite of the distributive property. We're taking something that's already multiplied and we're turning it into a distributive property problem. And if you weren't sure if you did it right, you can multiply the 4 out to both of these, and you should end up back with what we have at the top. Now, GCF doesn't just work with numbers, it also works with letters. You'll notice that both of these parts have an x in them. And remember that having an x next to a number literally just means multiplication. So we can pull out an x from both of these parts. So we already had a 4 pulled out, but now we're also going to pull out an x. And we're just going to rewrite what's in the parentheses, except we're going to pull out an x from both parts. So here we had 3x squared, that's x times x, but we pulled out one of them, so there's only going to be one x left. And then here we have 2 times x, but we're dividing out one of the x's, so all that's left is just the 2. And there we go. We have successfully factored out 12x squared plus 8x. And of course, if you wanted to check your work, you could do distributive property, and you should end up back at the top. Now, I said at the beginning of this video that a variable or a letter is basically just a number that we don't know what it is. But with all of these things we've been doing, we had no way of knowing what number that is. Like, how are we supposed to find out? Well, that's because we didn't have an equal sign in any of those expressions. But once you put an equal sign in it, it becomes an equation, and we actually can figure out what number this letter is equal to. So for example, here we have negative 4 times x, and it's equal to 12. And we need to figure out what number should go inside of this letter, inside of this blank, basically. So the way that we solve these kinds of problems is we try to isolate the variable, which is basically just a fancy way of saying we need to get the letter that we're solving for, which is x, by itself on one side of the equation. Now, this minus 4 is in the way, and so we need to get rid of this minus 4 to get x by itself. But we can't just go, okay, I'm just going to cross out the negative 4, because that would make this equation not true anymore. But the equation will always stay true as long as you do things to both sides of the equation. If you do something to both sides of the equation, it doesn't matter what you do, you can do whatever you want. So because this minus 4 is being multiplied, I'm going to do the opposite of multiplication, which is division. If I divide both sides by negative 4, then I'm going to get x by itself. So these minus 4s cancel out. And on the left side, we're just going to have x. And on the right side, we have 12 divided by 4, which is 3. And we have one minus sign, so the minus sign stays. And the cool thing about algebra is that you can always check your work by taking this number and replacing it back in place of x. and making sure that the equation is true. And in this case, it is, because -4 times -3 is positive 12. So we did the problem correctly. Now, that last problem we were able to do in just one step, because there was only one thing we had to get rid of. But most algebra problems have multiple things that you have to get rid of, and so we're going to have to do multiple steps. So to get x by itself here, we have to get rid of this 5 at the bottom of the fraction, and we have to get rid of this -3. So if you're not sure which one to get rid of first, technically you could do both. But if you want the easiest way to know which ones to do first, then we can use PEMDAS. Remember that this is basically just the order in which you have to do certain things in math. So whenever you're trying to simplify stuff, you have to do parentheses first, and then exponents, and then multiplication and division, and then addition and subtraction. But when we're solving for x, what we're actually doing is working backwards. So to get x by itself, we actually have to do addition and subtraction first, then multiplication and division, then exponents, then parentheses. You technically don't have to do this, but this is going to be the easiest way, is going backwards in PEMDAS. So here we have a -3, and the opposite of subtraction is addition. And that comes last in PEMDAS, so that's going to be the easiest thing to do first. I'm going to add 3 to both sides so that the -3 and the +3 cancel out. On the left side, we're just going to have x over 5. And on the right side, we have -1 plus 3. That's the same thing as 3 minus 1, which is 2. And now we've brought this down to just a one-step algebra problem. And remember that fractions are the same thing as division. So this is actually being divided by 5. So we're going to do the opposite of division, which is multiplication, and multiply both sides by 5. So these 5's cancel out. On the left side, we just have x. And on the right side, we have 2 times 5, which is 10. So this means that x in this equation is equal to 10, and that's our answer. Now in math, you're probably used to just seeing equal signs in every equation, but that's not always the case in algebra. Sometimes you're going to have an inequality, which is basically where you have a greater than or a less than sign. And you might remember back from like elementary school or something that the way you learned this is that it's like an alligator, and the alligator eats the bigger number. So in algebra, when we're solving inequalities and we're trying to solve for x, it's basically the same thing, except there are two main differences. The first difference is that we're not going to know what number x is exactly. Instead, we're just going to know that x has to be bigger than a certain number or less than a certain number. And the second difference is actually something that happens at the end. So I'm going to start solving this, and then I'll show you what's different at the end. So remember that it's easiest to do addition and subtraction first. And here I have a -1. So I'm going to do the opposite of subtraction, which is addition. So these cancel out. On the left side, we have -2x, and the sign is going to stay the same. And on the right side, we have 5 plus 1, which is 6. And now we just need to get rid of this -2, which is being multiplied. So we have to do the opposite of multiplication, which is division, and divide both sides by -2. So these cancel out. On the left side, we just have x. And on the right side, we have 6 divided by 2, which is 3. And one minus sign, so the minus sign stays. Now here's the big difference with inequalities. Whenever you multiply or divide by a negative number, the inequality sign has to flip around. So this was greater than, now it's going to become a less than sign. And our answer is actually x is less than -3. So if you wanted to test this out, you could basically take any number that's less than -3 and put it in for x and make sure that the equation's true. So earlier I talked about the distributive property, which is basically how you multiply a number out to something in a set of parentheses. But what happens if you want to multiply a set of parentheses by another set of parentheses? Remember, this is multiplication because there's no sign in between. In this case, we actually have an acronym that's kind of like PEMDAS, where each letter stands for something. And in this case, we're going to use the acronym FOIL. So to multiply these out, we just need to follow 4 steps, and the letters of FOIL will tell us what those steps are. So the first step is F, which stands for first. That means we need to multiply the first parts of each set of parentheses. So here we have an x, and here we have another x. So we need to multiply x times x. And x times x is x squared, because remember, that's what squared means. It just means multiplying by itself. The next step in FOIL is O, which stands for outer. So we need to multiply the outer parts together. And in this case, that's x times -2. Remember, minus signs always stay. So x times -2, well, you can't multiply a letter and a number, so it's just going to stay as -2 times x. And in algebra, we usually put the number before the letter. It would be kind of weird to say x times -2. That's just kind of weird. The next step is I, which stands for inner. So we're going to multiply the inner parts together because last time was the outer parts. And in this case, that's 5 times x. Again, we can't multiply those, so it's just going to stay as 5 times x. And finally, we have L, which stands for last. And we need to multiply the last parts together. And we can multiply these because they're just numbers. So here we have a 5, and here we have a -2. 5 times 2 is 10, and 1 minus sign, so the minus sign stays. So there we go. We've successfully multiplied these out, but there's actually one thing we can do. If you remember back from when we were talking about simplifying and combining like terms, these two parts here are like terms. They both have x. So we can combine these into one part, because here we have a -2x, and here we have a 5x. So 5 minus 2 is 3. So these can combine to become just 3x. But other than that, there's nothing else that we can really simplify. So this is our final multiplication of x plus 5 times x minus 2. Now, earlier I talked about something called factoring, which is basically where you unmultiply something. You take something that's already multiplied and then turn it into a multiplication problem. And for FOIL, which is where you multiply two things in parentheses, we can actually do the same thing. We can factor it. So this is already multiplied, and we want to turn it into two sets of parentheses. So because this is just an x squared at the beginning, if this was like a 3x squared or something, this would be a little bit different. But we know that they have to both have x in the parentheses. And they're both going to be x plus a number or x minus a number. So our goal here is just to figure out what number should go in the parentheses. And here's how we figure that out. All we need to do is figure out two numbers that add up to the number that's next to x and multiply to the number that's by itself. And if we can figure out these two numbers, then those are the numbers that are going to go in the parentheses. So let's list the numbers that multiply to 12. The first numbers that come to my mind are 1 and 12. 1 times 12 is 12, but if we add these together, we get 13. And we're trying to get 7, so these are not the numbers. But what about 2 and 6? 2 and 6 both multiply to 12. And if we add them together, we get 8. So close, yet so far. So that's wrong too. The only numbers left that multiply to 12 are 3 and 4. 3 times 4 is 12, and if we add them together, we get 7, which is the number we're looking for. So 3 and 4 are the two numbers that we're going to use for factoring. So this means that we can rewrite this equation as x plus 3 times x plus 4. And of course, if you had any negative numbers in this, if a negative number was one of your numbers, you would put minus instead of plus. So this has factored into x plus 3 times x plus 4. And if you wanted to check your work, you can use FOIL on this, and you should end up back at x squared plus 7x plus 12. All right, let's combine a bunch of what we've learned so far and use it to solve this system of equations. So if you have an equation like this one, 3x minus y equals 9, and you have two letters in it, if you have an x and a y or any other two letters, then you can't solve for those. You can only solve for it if you have just one letter. But if you have multiple equations, as long as you have as many equations as you have letters, you can solve for all the letters. So because we have two equations here, we can solve for two letters, and that's called a system of equations. So what we can do is we can solve for one of the letters in an equation, and then use that to solve for the other letter. So here at the bottom, this bottom equation, I'm noticing that x is really close to being by itself. So let's try to solve for x in this equation. So the only thing in its way is the 2y, and it's being added. So I'm going to subtract both sides by 2y. So these cancel out. On the left side, we just have x. And on the right side, we have a number and we have something with a letter, and we can't combine those. So it's just going to stay as -4 minus 2y. Now, this isn't very helpful on its own because, we're trying to figure out what number it's equal to, and all we've ended up with is something with a letter inside of it. But what I can actually do with this is now, because I know what x is equal to, I can use the other equation. I can plug this in for x, and then the equation will only have y in it. Let me show you how that works. We know that x is the same as -4 minus 2y. So let's rewrite the top equation, but instead of x, we'll write -4 minus 2y. So we're going to have 3 times -4 minus 2y minus y equals 9. And now this equation doesn't have any x in it, it only has y, which means that we can solve for y and figure out what number it's equal to. So here we have what should hopefully be a familiar pattern by now, which is the distributive property. So we need to multiply the 3 to both parts of the parentheses. So 3 times 4 is 12, and we have 1 minus sign, so the minus sign stays. And then here we have 3 times negative 2y. 3 times 2 is 6, and the y stays. And we have 1 minus sign, so the minus sign stays as well. And then the rest of the equation is just going to stay the same because we didn't do anything with it. Now here in the middle, we actually have like terms. We have two parts that have a y in it, so we can combine them. So the minus 12 is going to stay put because we're not doing anything with it. And then here we have minus 6y minus 1y. Remember, there's like an invisible 1. So negative 6 minus 1 is negative 7. And then the y is going to stay. And we didn't do anything with this 9, so this is going to stay as well. So I'm going to erase this and then move this up to the top so that we can keep working with it. So now this looks a lot simpler than it did before, but we still have things to get rid of. Remember, we want to get y by itself. So we're going to go opposite of PEMDAS. We want to add and subtract first. So we have a minus 12 here. I'm going to do the opposite of minus, which is plus, and add 12 to both sides. So these cancel out. On the left side, we have minus 7y. Don't ever forget the negative signs. That's probably the most common algebra mistake. And then 9 plus 12 is 21. And now here, remember that this is multiplication. So we're going to do the opposite of multiplication, which is division, and divide both sides by negative 7. The negative 7s cancel out. On the left, we just have y. And on the right side, we have 21 divided by 7, which is 3, and 1 minus sign, so the minus sign stays, which means that y is equal to negative 3. Now we know that y is equal to minus 3, which is cool and all, but we can actually use this to now figure out what x is equal to as well. We can choose either equation. I'm going to choose this one because x is closer to being by itself. All we have to do is replace y with negative 3, and now we'll know what x is equal to because x will be the only letter in the equation. So let's rewrite this equation, except instead of y, I'm going to put negative 3. And I'm putting it in parentheses because we're trying to make sure that we know that this is multiplication, because this was multiplication before. And if we didn't put this in parentheses, then it would say 2 minus 3, which is subtraction, not multiplication. So we can go ahead and simplify this, and it's 2 times negative 3, which is negative 6. And now we just have a one-step algebra problem. So we just need to get the minus 6 out of here to get x by itself. So I'm going to do the opposite of subtraction, which is addition, and add 6 to both sides. So these cancel out. On the left, we just have x, and on the right, we have negative 4 plus 6. That's the same thing as 6 minus 4, which is 2. So x is equal to 2, and y is equal to minus 3. Those are our final answers. So those are the basics of algebra. Those are the things that you need to know to succeed in basically any algebra topic. When I was tutoring students, the number one thing that was holding them back was that they didn't understand the basics, and that made it hard to learn any other lesson. So if you have these things down, then you're ahead of a lot of students. But if you think you have these down and you're ready to start learning some harder topics, then you can watch this video where I go over some more difficult problems. And if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.